back to Easy Chemistry by Vennela. This is the part 2 of the Peracids. Here, regioselectivity in epoxidation. Regioselectivity in olefin epoxidation, it is olefin. If molecule having highly substituted double bond or more nucleophilic is selectively oxidized. That means, here example. Here reagent is MCPBA because which is low cost, very cheap, soluble in solvents. Here solvent is DCM. Here in this epoxidation is take place. Second example. In this which double bond is take place? Epoxidation. Here this one because it is more substituted. If you see this type of examples, it take place epoxidation on both sides because there is no preferably you can take an substitution double bond. So next, here isolated double bond is highly nucleophilic than conjugated double bond. Here example for that. MCPBA DCM. Here at which double bond is take place epoxidation? This one because these two are in conjugation. Here the point is isolated double bond is more nucleophilic than conjugation. So here it take epoxidation like this. So next point is stereoselectivity in epoxidation. This is also in olefin. Here two types. One is steric crowding and another one is chelation. First, steric crowding. Here I am giving directly an example, then you can understand easily. Here methyl, MCPBA, DCM. Here methyl and epoxidation in below the plane. Why? Here epoxidation will take place opposite side of the bulky group. Here it is above the plane. The group is above the plane. So epoxidation will take place in below the plane. Always sterically less hindered phase. Another example. Tertiary butyl, MCPBA, DCM. It is below the plane. So it will attack like above the plane. Like this. So next, this is the one of the CSIR-NET exam question. MCPBA, DCM. Here it is above the plane. Then epoxidation is below the plane. So again it will react with LiAlD4. So the product is like this. It is above the plane. How we can write like this? Then you can write benzene like this. This is the double bond. Here methyl group is there and here hydrogen. You can write like this. Then you can easily understand. Sorry. Here methyl group, here hydrogen. It is below the plane. That means you can write like this. It is axial position, it is equatorial position. Then it react with LiAlD4. So it will attack only axial position like this. So final answer is, here it is above the plane and it is below the plane. The product is only axial position. This is the final product. So the next one is chelation. OH react with MCPBA DCM. In this chelation, why I am writing like this? This is above the plane and epoxidation also will take place in above the plane. Why? In chelation, OH and NH2, these two are in chelation will take place epoxidation direct similar direction of the chelating group. If chelating group is above the plane, epoxidation also take place in above the plane. If they given like this, both OH and amine group is there, then epoxidation, how it take place? The epoxidation is in below the plane, because when OH and amine will both will given, you can priority first to amine group after OH group. So next one, in this example, both chelating group and sterically crowding group is present. This is chelating group, this is crowding group. So epoxidation will take place at crowding or chelating group? Chelating only. Here chelating group is like this. Both chelating and steric crowding is present, then controlled by chelating group only. This is chelating group and this is crowding group. Both will present, then controlled by chelating group only. It is exo. It is endo. Exo is sterically free. Endo is sterically crowded. So which is the major product? Endo or exo? Exo, because you have to consider sterically free. Exo. It is major. It is endo, minor. I am giving another example, then you can easily understand. Here hydrogen and here methyl. MCPBA, DCM. It is exo. It is sterically free. Endo. It is crowding, because here this side is lighter group is present. So that is the reason it is the sterically free. Wherever the sterically free is, that is the major product. Here major and minor products is based upon the sterically less hindered or sterically crowded, based upon only that single reason. Sterically free or sterically crowded. If it is sterically free, that is major. What it is, sometimes it is exo or sometimes it is endo. The limitations for peracids. Peracids are unable to oxidize conjugate olefin. This is the conjugate olefin. Unable to oxidize conjugate olefin. Next, alpha beta unsaturated carbonyl compound competition with Bayer Williger oxidation. This is the example. Here you can insert oxygen. MCPBA, DCM. Simply you can insert one oxygen. Then it is Bayer Williger oxidation. Next, internal double bonds are highly reactive over terminal double bonds. Trifluoroperastic acid also used in epoxidation in presence of basic buffer solutions only, because it is very strong, high cost. So basic buffer solutions are NaH2PO4 or NaOH or KOH. So if you found this video helpful, please like, share, comment and subscribe to Easy Chemistry by Vennela. Thanks for watching.